everyone. I am here to present our term paper titled Video Prism, a foundational visual encoder for video understanding. This work explores a powerful approach to video modeling that proposes a single, unified encoder capable of handling a wide range of video understanding tasks, from action recognition and retrieval to captioning and scientific applications. I'll be presenting this on behalf of my team, Shagun, Dipanshu, Yogesh, and Sai, as the part of the Deep Learning and Applications course. Let's start with the basic question: what is Video Prism? So, it is a frozen general purpose video encoder designed to work across diverse video understanding tasks such as video classification, text video retrieval, video captioning, and video based question answering. The term frozen is here. It means that once trained, the model isn't fine tuned on specific tasks, instead, it generalizes to all of them. Video Prism is trained on enormous dataset of over 600 million video text pairs and yet achieves a state of the art performance on the 31 out of 33 benchmark tasks. This makes it a powerful candidate for a future where we use one universal encoder for many video tasks. Next, talking about the key features. So, what are its core features? First of all, no fine tuning is required. It acts as a plug and play encoder across multiple tasks. Dual understanding, it captures both appearance like scenes and objects and motions such as motion, actions and temporal changes. Third is the two-stage training. It combines the benefits of supervised and unsupervised learning by using both clean captions and noisy video data. Strong generalization. One of the standout aspects is its ability to perform well even on completely unseen domains like scientific video data. Okay, model architecture. So let's now break down the architecture, starting with the stage 1. This stage uses 36 million high quality video caption pairs. A video encoder and a text encoder are jointly trained so that the model learns to align the semantic space of videos and text using a contrastive loss. In simple terms, like if a video shows some riding a bike and the caption says a person is riding a bike, so the model learns to bring those representations close together in the embedding space. This enables it to understand what a video is about in natural language terms, which is crucial for downstream tasks like retrieval, captioning, and question answering. Okay, so now talking about the stage 2, masked video modeling. Stage 2 shifts the focus from video text pairs to video only data. Here the model is trained on 582 million clips, many of which come with noisy or no captions. This method is called masked video modeling, which is similar to the masked language modeling in NLP. The model masks parts of the video features and tries to predict or reconstruct them. Talking about the two major innovations that are introduced here are global and token wise distillation, which means that this encourages the model to reconstruct both high level video meaning and fine grained patch details. Next one is the token shuffling. By shuffling visible tokens before decoding, the model is forced to learn motion and context rather than memorizing positions. So, this helps the encoder develop robust motion understanding, which complements the appearance learning in stage 1. Okay, so let's start with the direct comparison between Video Prism and other strong models like COCA, Intern Video, and UMT using a frozen backbone across three popular benchmarks. We see the performance across Kinetics 400 for appearance based classification, something something V2, which is for motion understanding, AVA for spatiotemporal action localization. So Video Prism achieves plus 7.1% gain on Kinetics 400, plus 5.4% on SSV2, and plus 9.5% on AVA. These are the major improvements over previous models, especially considering that no task specific tuning was applied. This shows that the model has effectively learned a general visual and temporal representations that transfer across tasks, a critical goal for foundation models. Now let's look at how Video Prism performs on specifics on scientific data sets like those found in AI4 science benchmarks. These domains often involve animal behavior tracking, for example, insects in lab settings, and usually require domain specific models to perform well. But what's impressive is that Video Prism, with no additional fine tuning, outperforms these specialized models, even though it was trained on general web scale data. This shows strong domain generalization, which is especially valuable in areas like biology, neuroscience, and ecology, where collecting and labeling task specific video data is both expensive and time consuming. The overall benchmark summary, that is the 31 out of 33 wins. Finally, here we see a comprehensive comparison of Video Prism's performance across 33 benchmarks, which covers the tasks like video classification, action localization, text retrieval, video captioning, and question answering. The chart shows the delta scores over prior state of the art models. We can notice how many tasks show significant gains, like plus 22.4% on charades for classification, plus 18.3% on MSRVTT for video question answering, and plus 11.1% on AVA and MSRVTT captioning. So, in total, Video Prism outperforms previous models on 31 out of 33 benchmarks. This demonstrates that the model isn't just strong in one area, but it is robust across modalities, domains, and tasks, all using a single frozen encoder. And these results validate the core idea behind foundation models: one model, many tasks, with minimal or no customization. So, do we get to know out of these experiments overview? So, the key point to remember is that Video Prism is evaluated using a frozen backbone, meaning the model score parameters are not updated or fine tuned for any specific task. Despite this, the model achieves state of the art performance on a wide range of tasks, from scene classification to action recognition, and even cross model retrieval. This level of performance without fine tuning is a strong indicator that the model has learned a deep transferable representation of the video content, capable of understanding both what is in the video and how it changes over time. It is the generalization ability that makes Video Prism an ideal candidate for building universal foundation models, model that can be reused across tasks with minimal overhead. Now, moving forward to the how the Video Prism is trained. So the strength of Video Prism can also be attributed to its massive and diverse training dataset, that is total of 619 million video text pairs. These are divided into 36 million high quality human annotated videos which are used in stage 1 for contrastive learning. These include YouTube clips, educational content, and curated data sets with strong video text alignment. The second is 583 million noisy video text pairs used in stage 2 for masked video modeling. These videos are paired with text from ASR transcriptions, video metadata, or captions generated by the LLMs. Now the question arises that why does this matter? So the answer to this is because the high quality captions give the model semantic grounding while the massive scale of noisy videos provides visual diversity and temporal variation. This combination allows Video Prism to learn both language aligned representations and rich visual features, making it capable of handling everything from natural scenes to scientific lab recordings. Okay, so now let's start things off with a question. How well does Video Prism actually perform on standard benchmarks? So here we are looking at Video Glue benchmark, which evaluates general video understanding using a frozen backbone. So no fine tuning, just raw generalization power. On Kinetics 400, which is all about human actions, Video Prism pulls ahead with a strong plus 7.1 gain. With moments in time, that is the MIT, and SSV2, which both require modeling subtle temporal cues, we again see impressive boosts of point plus 6.8 and plus 5.4. The biggest jump happens with diving 48, a staggering plus 11.8, which tells us Video Prism really nails the fine grained motion patterns. Now, the data sets like charades and ActivityNet, which simulate real world complexity, show consistent gains of plus 7.1 and plus 0.8. And finally, in AVA and AVAK, which are all about action detection in space and time, we see gains of plus 9.5 and plus 5.9. So, even with a frozen backbone, Prism delivers strong, reliable performance across a wide spectrum of tasks. So, moving forward, we'll see how it handles retrieval tasks where things get a bit more interactive. So, here we enter the retrieval space. So, this is basically how well Video Prism can link videos with natural language without any additional training. On the left, we can see it is the video to text retrieval. So on MSRVTT, we are getting a solid point plus 6.3 improvement. On Vatex, the model stays strong with a plus 3.5 gain. And on ActivityNet, which is large and open domain, we see a fantastic plus 9.6 boost. Now switching to text to video retrieval, again, which is on the right, Video Prism gives plus 8.8 on MSRVTT, plus 9.3 on Vatex, and plus 9.9 on ActivityNet. So we can clearly see that this is a two-way street where Video Prism is driving in both directions, video to text and text to video with very high accuracy. So what this tells us is that the model is not just watching the videos but actually understanding them in a language aligned way. So all right, now that we have seen retrieval, let's go on a level deeper with captioning and visual question answering. Okay, so now here's where things really gets exciting. We are testing zero shot video captioning and visual question answering. This means that the model is being asked to describe or reason about a video without having seen examples from that task. So for captioning on MSRBTT cap and Vatex cap, Video Prism achieves plus 11.4 and plus 7.8. Really impressive narrative generation. On UCook 2, which involves step by step instructions, we have seen a plus 8.6 bump, showing its strength in procedural understanding. For question answering, on MSR VTTQA, there's a whopping plus 18.3 jump, and on MSVD question answering shows plus 16.9, and next QA adds plus 4.4. So, yeah, this isn't just captioning what's visible. Video Prism is answering nuanced high level questions about video content. So here's something different, that is CV for science tasks. These are domain specific data sets where models often struggle without specialized training. Fly versus fly. Seen a gain of plus 3.4, great for behavior classifications. CAMS21 holds steady at parity with domain experts. In CRIM13 datasets, both side and top views shows consistent gains of plus 1.3. KBR related to robotics shows a modest plus zero point 0.6 improvement, but the highest standout is Chimp Act with a jump of plus 5.8, which is impressive considering how tricky behavioral ethology tasks are. In short, Video Prism isn't good on benchmarks. It shows promise in scientific and low resource domains too. And let's put everything together. So across all the evaluations, we got to know that video glue proves its general understanding, retrieval shows its semantic grounding, and captioning and QA reflect its deep reasoning, and science data sets show its adaptability. So, what makes Video Prism special is that it doesn't need fine tuning to outperform. It generalizes exceptionally well in zero shot settings across all these domains. Now, while Video Prism performs impressively across benchmarks, it's not without its limitations. First off, the scale is both its strength and its weaknesses. Training on over 600 million video text pairs means it's extremely resource intensive. Not everyone can replicate this kind of setup. It also relies it also relies heavily on the quality of the pre-training data. So there's noise or bias in the dataset. It may affect downstream tasks. Then there's the issue of temporal granularity. In tasks that involve super fast actions or very subtle frame to frame changes, it sometimes struggles to keep up. Also, it's not designed for real time inference. So, using this in applications like live surveillance or streaming videos understanding is still a challenge. And finally, even though it's powerful, why it makes decisions is often a black box. That is, interpretability is still an area for growth. Looking ahead, there's a lot of exciting directions where this work can evolve. First, we would love to see lighter, more efficient versions of Video Prism that can run in real time or on edge devices. Making the model more explainable is another key area. Users should be able to understand why a prediction was made, especially in sensitive domains like healthcare or law. Then there's multimodal fusion. Imagine combining video with audio depth maps, or even 3D spatial data to enrich understanding even further. Video Prism could also be extended to better handle temporal detail using smarter frame selection or frame interpolation. And finally, the model to low resource domains like medical videos or security footage could make it truly universal without needing massive data sets. So, now to wrap things up, Video Prism proves to be a powerful and versatile frozen video encoder. What makes it stand out is its ability to handle a wide spectrum of video understanding tasks, from action recognition and retrieval to captioning, question answering, and even scientific video analysis, all without needing any task specific fine tuning. It is trained on a massive 619 million video text pairs using a thoughtful two-stage approach. One stage focused on learning semantic alignment with text, and other on capturing rich temporal and motion cues. And the results speak for themselves. State of the art performance on 31 out of 33 benchmarks, outperforming not just general purpose models, but also those tailored for specific domains. Perhaps most impressively, it shows strong generalization not just in popular datasets but also in zero shot settings and unseen scientific domains. That's a huge step toward building universal, robust video foundation models that can scale across applications and domains. So, overall, Video Prism is not just another benchmark hitting model, it's a foundational shift in how we approach video understanding at scale. So, before I close up, I just want to highlight that Video Prism isn't just about numbers and benchmarks, it's a strong step toward building truly general purpose video AI systems, ones that can adapt across tasks, domains, and real world use cases. It shows us how powerful a frozen unified model can be and opens up new opportunities in areas like scientific research, education technology, and content research and real-time understanding. There's still more to explore, especially in areas like interpretability, efficiency, and multimodal learning. But this work definitely paves the path forward. Lastly, I would really like you to thank you so much for your time and attention.